Everyone. Today I will show you how you can use our OpenMP-based tool to find the length of the LCS of two DNA sequences. So at first we'll start with downloading the code from our GitHub repository. So you'll find the link of the GitHub repository in the description of this video. So we can either download or clone this data or clone this repository from using this green button here. So you can use this download option from here or copy the URL to clone this repository. So I will clone this repository. So I have copied the URL from here, and now I will use the terminal to I will clone it in my desktop, and I will use git space clone space the repository name to clone this repository. So it's cloning this repository in my desktop, and you can see it from here. So now I will use a text editor to open this code, and I'm using Sublime Text here. So I'll go here and I will open this directory. So inside this directory there is a tool directory where you will find the tool for finding the LCS. So now I will try to compile this, compile the program. So I'll go inside the directory, the repository, and the tool directory, and now I will make this program, C program, using the make command. So it looks like there is a problem, error while doing this. So you may face this issue if you are also a Mac user, and if your CLang compiler doesn't support OpenMP. So in my case, I have upgraded the GCC version. You can find the details about how you can resolve this issue in the GitHub wiki page. And I have updated the GCC, I need to specify the new GCC version in my makefile, so which is inside the tool directory, and there in line number 27 there is the name of the compiler. So here I will specify GCC-8 instead of GCC. So if you are using Linux or Windows, you will be fine, because usually the version of GCC on those platforms usually has built-in support for OpenMP. So now that I have fixed it, let's try compiling it again. So I'll run make command again. So it looks like this time it has done it. So if I see the contents of this directory now, there is an extra executable file here, and now that we have compiled our program, we will be able to run this program. But before that, we need two sequences which we will compare. So let's download the sequences from website. So I will use University of California Riverside's website for random DNA sequence generation. You can use any source you want, or you can also use real-world DNA sequences. In the description box of this video, I have provided this website, this URL, and also URL for finding DNA sequences of like real-world DNA sequences. So now I will download a very tiny length of tiny DNA sequence. So I'll generate it here. For demonstration purpose, I'm keeping it very small. So I will go to the text editor, and I'll go to the data directory, and I will create a new file, and where I will put this sequence. And before that, I will specify the length of the sequence. and now I'll save it as my underscore data.txt. So now that I have saved it, I can download another data set. Let's download it just 127. We can change the GC content here, which specifies how much G and C will be in the sequence. So I'm just changing it. So it's done, and I'll copy this one again, and I'll paste it here. And the second one is 127. And I need to specify the number of unique characters that we have here. So as you can see, in our case here, this is the DNA sequence data, and there are only 4 characters, which are A, T, C, and G, and these are A, T, C, G. So I have mentioned this. So this is it. Our input file is ready now. So we'll try to run our code now. So to do that, I will run /find LCS, and then I will specify my input data file, which is in the /data/my data.txt, and after that I will specify the output file where I want my output to be written. So I will do it in output.txt file. So this is it. I have run this, and it should have created a output.txt file. So let's see. So yeah, as you can see, inside the tool directory there is a new file which is output.txt, and in the first section you can see the description of the input file, which the input file name, and then the lengths of the two sequences to like two sequences, and after that the results from the parallel execution and the results from the sequential execution. And in the results of parallel execution, you'll be able to see how many threads were used. Actually, this program will try to use the maximum number of threads available. So in my case, were only 4. There were only 4 threads, and the length of the LCS is 65 here, which will be same for both the parallel and sequential versions. However, you can see that the time here is like much larger than the sequential implementation. So for small data sets, it happens because there are some extra overheads of communication overheads and synchronization overheads associated with parallel executions. But if you increase the length of the sequences, this parallel version will perform significantly better, which you can find, which we evaluated in our study. So this is it. Thank you for watching this video. Bye bye.